probably. And also we can do something else. Tick, tick, tick.
Okay, it should be live in a few seconds.
Yes, it's live. It's alive. So I'm going to post this link so everyone can join, yeah? Can I post it? Go.
I don't know, it seems to me that video playback is somehow broken. No, it's working.
Give me a second. There is something. It shows that you are showing your studio youtube.com.
Okay.
And I think it's fine. Or maybe not. I'm not sure what you are showing here.
I'm showing my ID. I can see it on the stream. Everything is fine. We can start. Do you want to make a small introduction?
So have we started? I'm not sure.
Yes, we can start.
Okay, so I have posted the link. Hello everyone. I'm Oleg and here's my friend Bogdan. And today we will continue our previous episode regarding runtime immutable checks, or immutability checks, because we haven't finished it yesterday and we would like to continue. And what we have done, basically, we have explained what we're going to make. In short, we would like to create such a library, which helps you to verify, have someone change into your variables during runtime in some method. And we have added only support for slices currently. And we left this, I'm not sure what we have left for the future, probably other types, maybe something else. Do you remember what we need to make today, Bogdan?
Let me check. I think we can do multiple different things actually. We can potentially just continue to work on the slices and maps and some other types. We can also simplify the task for us, just for example, for all primitive types that are in slice, let's say, we can for all primitive types that are in slice, we can do automatic hashes if we interpret them as a byte slices. That can be interesting. So we can like automatically support multiple different things.
Sounds reasonable.
Let's try to do that. So let's say this is ME because or let's say ints. Yep. And here we can have floats. And we can make here a float 64, let's say. Why not? And we can set there a float. Let's use some other value. We can make it even bigger potentially, like 10 elements. And let's make ensure immutability of ints Then ensure immutability of floats. And then what we're gonna do here, we can make mutations strictly here, you know. You can say ints 0 set 2 floats 0 set 2.0, something like that. So if we run our current code, it basically fails, and it fails somewhere, we don't know where. And we don't know basically anything about these values and everything like that. What I also think what we can do, we can make this type potentially like a compound type or some more sophisticated type. Let's say we can use some kind of a value snapshot. And it will be a struct. And this struct can contain checksums, because why not? But it can also contain, let's say, string snapshot. I would like to make it mutable or optional.
Wait a second. What do you mean by string snapshot?
I'll show it to you.
Idea.
1 second.
Okay.
It will be optional to capture, actually. So we can make it only in debug mode or whatever. The idea is to capture string representation of a value.
Yeah, agree. It's fine for debug, but maybe it's not so useful for real usage.
Yeah, it's gonna be a problem for real usage, but it should be fine. So we capture here a snapshot, capture checksum map. Okay. We can, what else?
Do you know what? I was thinking about to slightly change API for our ensure immutability function.
Yes.
Because currently it looks like we need to create new defer per new variable, and
Yeah.
maybe it's not so cool. Maybe it's better to ensure immutability, just list of variables. But I think we can leave it for the future because it's not so hard to add it, but maybe it's not so important for now.
Yeah,
We'll see.
We can just like return function and call it or whatever. It can be done, not a problem.
And also, I'm not sure, do we need to expose this value snapshot function? Because probably it's not the type which we are going to export.
For now, I think it's fine. It possibly can be. We can possibly even export it for some debug purposes, or if some other library wants to do something with these snapshots. We will think about it later on. For now, it's anything internally won't be accessible. Maybe we can define some certain methods on snapshot to export certain, properties. Okay, so we can create empty snapshots now. Redefine it here. We can now print snapshot. Okay. And this thing we can rename to new snapshot. New regional.
Yeah, now it's much better. I mean, there's an additional type. Basically, everything can be encapsulated into this type as different methods. And we do not have like floating in the air capture checksum map, which basically says nothing.
Mm-hmm.
And that's cool.
And what I wanted to do is basically here just check like snapshot dot string snapshot is empty. If it's empty, we can capture it. You know,
something like value dot string.
Yeah. fmt dot sprintf. So it will help us to understand what is actually happening there.
But I think it will just capture the first value which we have passed. And if it is a pointer, probably it will just print a pointer and that's all. So I'm not sure how bad it is, but maybe it's not so useful as we might think. And sadly, I do not see. Okay, I see.
Value element. I'm not sure where to capture it. Maybe here in ensure immutability it will be better way to do it. Because here we are gonna deal with reflect values.
Yes, this is one thing I wanted to mention before, because reflect value they probably give us not what we have expect.
Yeah. Let's do it here then. New value snapshot. We can actually also pass interface there.
Agree. And we'll just print what we have passed. Just probably it's like it should be FMT as printf.
Mm-hmm. Just printf. What is wrong?
You need to place percent before v and also
okay,
add,
okay. Okay.
Yeah, also add a hash. Yeah. Oh, sorry, plus. Yeah. Okay.
Plus is fine. Okay, so we capture it here, then we capture it once again, and it should show us something. Why do we have values. So we have maps, and for some reason, okay, so this is a string representation of our value, yeah? This is the string snapshot of our do you remember how to add type as well here? So,
T, capital T.
I mean, like, there was some way to...
So put a hash here.
If I
Like
put
a hash. Yes. And this should work.
Yes, that's great. That's what I wanted. So we know, okay, this failed because the new value is the following one, the old value is the following, and so on. Hashes are different. Yeah? And this also fails. Or not?
Probably.
No, I think it doesn't fail. So we print everything here. If we remove it, so we fail on floats as well. But how do we support floats? We don't support floats in any way.
We do not support it yet.
Yes.
And that's why we need to just start a new case for floats. And this should be fine.
If I remove ensure immutability for ints, and I just run it for floats, it still fails on floats. As you can see.
Yeah, but I don't get what you're what you're expecting. Just because we do not have support for floats, of course it will fail. Why not? No, wait a second. From the other side, we have a...
It fails because we now support string snapshot and we compare it using deep equals. So it magically works. You know?
Mm-hmm.
Because for floats right now, checksums are literally identical. But string representation, string snapshots are different. So what we want to do here, we need to make a deep equal of checksums explicitly.
Mm-hmm.
So it won't fail. Yes, it won't fail. So we don't want to rely on string snapshots in that regard. Okay. Do you want to continue, or you want me to do the support for...
No, feel free to add it.
Okay, so we can say reflect float 64 and so on, so on, so on. But how we're gonna do that is just maybe I want to do it slightly differently. So
I have an objection.
Yeah.
Just because adding reflect float here will not work, as far as I remember, because running item.int over float will give you a cake. You need to run float method on reflect.
Yeah, I'm not gonna do that at all,
Okay,
actually.
okay.
What I wanted to do is just say the following, like we have this value and I need to find what is the actual element type of this slice.
And it's exactly lm.value, dot type.
I think element just returns, it works for interfaces and pointers, but not for slices. You know? For slices, you still like are forced to use index.
What is the problem? Wait a second.
Is nil, is 0. We can check if this is a 0 slice. If yes, we can add something to our checksum to mention this was the 0 slice. Okay, let's do that. So, okay, if...
Why not put its len and leave it as this?
1 second. If slice is 0, what I wanted to do is just like, okay, I checked if this is 0 or not. We will fill it later on. I check if it's 0 or not. If it's not, then what I can do, I can say value index 0 dot type dot size, and size should be size in bytes. Yep. And I also need to maybe check alignment. I'm not sure. No, but size should be aligned already. Okay. Dot size. What I also can do is just like value. Can I get an address? Returns a point. Can I get a slice header from it? Slice 3, slice, call slice. Unsafe address. That can work. I'm still gonna need it, so can say this is unsafe address of my value. Now I can cast it to slice header as an address to slice header, no?
Yes, you can, I think.
So I'll say my unsafe address it's a uint pointer. And I can say this is I don't remember how exactly to do that. This is my value size in bytes. And I can say this is safe pointer. What is happening? Okay. Okay. For some reason, I can't go. Okay. I'm not sure it's gonna work. I can look at examples somewhere else. But it seems to me it should work this way. Get. I think when you navigate somewhere, I lose my controls.
Really?
Yeah.
Okay, I will. I think.
No, it's actually fine. It's just I have this slice header. The question is how to get it. If I check unsafe address, give me unit pointer for a pointer, which ensures it can recognize unsafe pointer. Okay, so I can cast it like that as I wanted to do that. It will be slice ptr. Yep, and now I can cast it, hopefully, so to reflect slice header. Okay. On slice value. So size is 8. This is fine. So what I want to do is check some examples, how I did that before, because I don't remember exactly, but I know where to look at it. So if I look at, I think arena buffer, maybe here. So I have a pointer. Here should be a reconstruction. So this is the slice header actually. So I can reconstruct this slice header manually if I know what it is. And this is how you're gonna construct it. I don't know if you can see what I'm doing right now.
No, I don't.
So the question is if I can do something like that. I basically have a pointer. I need to recast it as a pointer to bytes. It should be possible, yeah?
Looks so.
And look at it as a bytes, yeah, as a byte slice. Let's check that. Yeah, so it looks like what I want it to be. The problem is I should have 8 bytes here, but I don't have 8 bytes, I have more.
How many?
I can basically copy paste output for you so you can see it, because you don't see it, yes?
Yeah.
So this is the output right now.
So it's 8.
Yeah, it should be 8, but it's not 8.
But I see 8 as the result.
Yeah, 8 is the size here, size in bytes, which is fine for because we have int64 actually there inside.
But maybe you need to.
And I expect to see a different.
So maybe because you got the size of a pointer, not of the slice. I mean underlying array, isn't it?
Yeah, but this is fine.
Okay.
At that
So what is the problem then?
What if I check, what if I log value as well here? The output is the following. Let's run this in debugger to see what is happening there actually, because I just can't grasp it. Maybe it's because too late, maybe not.
To be honest, my eyes are pretty tired, so it's hard to follow.
Okay, so this is a slice, as a byte slice. Okay. The value is type of reflect type unsafe pointer. I can look at like reflect slice get header. Recast it as if I create a pointer to new slice. Pointer. Length is 10 and capacity is 10. The question is how it can be, because our length should be what if I do it here? You know? Yes, great. So at that particular point, everything is fine. The data address is the following. and length and capacity is the following. So this is great. When I pass anything, I pass as a oh, I didn't. Okay, let's change this. And now what we should see is integers. Yep. This is the length, this is capacity. Okay, it seems to be it's great. What I need to do now is just work with it as a pointer to byte slices, to byte slice. And it works like that. But if I make it bigger, slice as a pointer to byte slice that I dereference. Yeah.
Yep.
Value. This is a byte. But I need to say that this byte slice size is actually a lot bigger, because it is. You know, I can't say, yeah, so I actually need to go back to my slice header, and now target slice header. Yeah. Now in this target slice header, I can set length as reference length, or I need to basically multiply it by the size of value in bytes, and capacity as well, maybe, you know. If it's possible. All I need to do is just like, this is uint pointer, this is simply int, so I can change it, you know. And now it's gonna be a little bit different beast. Okay, so if I recast it once again as a this slice header, I need to get address of it, change it to unsafe pointer, and then recast it as byte slice. Let's add one more value here. Yay! That's what I wanted to see. I wanted to see it as a slice of bytes. So if I put it something that is bigger than a byte, let's say I should see how it moves, as you can see. Yep.
Sorry, I was on mute. Yeah.
Okay, so now we can interpret anything, basically any slice of any primitive value as a slice of bytes. And even if it's pointers, if it's a slice of pointers, it's still fine because we don't want these pointers to be changed. So we can actually interpret anything in a slice as a byte slice. Am I wrong or not? So like if we have a slice of like pointers to int, then it's still fine because we don't want these pointers to be changed when we check for immutability. Am I right?
I think so.
So we can basically use now, we can use our target slice as byte slice, and we can use it for hashes. So we can just go and write everything as a huge byte slice. And that's it. Now we can support anything, any primitive value. We're not going to like go inside. If we have a slice of pointers to some to some like complex structures, we still need to reference every reference every structure and verify it as a separate thing. But we still need to capture all these pointers, and that's what we're gonna do. The only potential problem will be that if someone gonna pass like a like a pointer to a stack allocated array, let's say, or something like that, and stacks in Go can be movable, you know.
Yeah.
But if you try to pass anything like that as empty interface, it will definitely escape to heap. So it's not going to be possible that you can pass anything here that is stack allocated. So this is fine.
Mm-hmm.
So all we need to do is just like deal somehow with zeros, and to deal with zeros, I believe we need to add something to a checksum, like some dummy value for zeros. So like if this is 0, we're going to put something here, like value. What do we have as a type? uint64. Value pointer as uint64. Yeah, fine.
Yes, looks reasonable.
So if I go back and I'm not gonna change it to anything, that should work just as it works right now. I can remove this stuff here. Now floats should work, ints should work, everything should work. So I didn't change int inside, but floats should still fail. And yes, it fails. And it says, okay, you have something like that. The hash is here, and it's different here. Right? Maybe we want to change this panic message to make it more comparable, let's say. What do you say?
We can try.
So
I
what
think
if we say like okay, so this will be a regional snapshot, then line break, and this is, oh, no, it's a new snapshot, and this is a regional snapshot. And like that. So, okay, you have panic, mutation of immutable value detected. Now, what we also want to do, maybe split checksums as well, so we can see, like we can compare checksum separately and a snapshot separately. New snapshot, checksum, and the regional snapshot checksum. Can maybe split it somehow. Okay. And let's duplicate it. I forgot something. Checksum, string snapshot. And I have 4 expected values. What is wrong here? Inspection. Should I concatenate everything back? Okay. To compare, I need to have the same lengths of okay, now it's a lot easier to compare. I think we can finish on that side. So what we did, we basically added support for any type of slice without actually checking the underlying structures. Maybe like if a slice contains other more complex structures, we're not gonna check them and trace their pointers, but it's fine, we can work on it later on. So we have support for ints, floats, and whatever complex structure. If we, for example, create some kind of a, let's say, type person struct, and we're going to have let's say what, age. What else we can have here? I think it should work basically as well.
Yeah, because there's something like casted simple byte size, basically like a raw chunk of memory.
Yep.
And it's hard to imagine something else.
So if I'm going to
Most
change
best.
age somehow for this, or set age for this first person, let's say 12, and here I can.
You know what?
Yep.
There's a problem.
Mm-hmm.
That's because for now it should work. Just because person is a simple structure.
Yeah.
Everything is fine. But if you will add a pointer,
yeah. As I mentioned before, we don't trace pointers for now. We can add like support for pointers later on here. So we're going to like capture this thing and then check if inside value is
if there is no pointers,
if it's a struct, map,
types,
or other slice or whatever, we should go and and basically continue capturing snapshots for it. So we're going to capture, like, even if it's a string, let's say, yeah. So let's say name here. String is, by the way, pointer to string, something like that. Or let's say maybe parent, and it's a something like that. Yeah, it's not gonna work obviously now, because I can go and change the age of the parent and we're not going to track that, but this is fine for now. Yes, so it detected that we changed the age of the person. Yep. Any ideas, any comments? Can you hear me, Oleg?
Sorry, I was on mute. Yeah, I hear you. Pretty well.
Okay, so we can continue to work on other complex structures later on.
Sure.
But now the progress is fine. So before we could do only integers, now we can do a lot more with this simple change.
Yeah, and please do not forget to push it on a branch.
Yes, I'll add it as a separate PR maybe for a second day, let's say.
Yeah, PR even better.
Okay, thank you then, and see you next time.
Hey, bye. Probably it's time to click stop stream.